Any questions on that so far?
Yes.
Okay.
Where do you get the hydrogen from? You just pull it out of thin air?
You don't.
So why can we just like add that and just add water?
Well,
Good question.
let's go back a second. Balance the following reaction which takes place in an acidic solution.
Oh.
What does acidic solution mean? It means you have floating around here H plus. Basically, it means is you have as many available H pluses as you need.
So you have plenty of them.
Yeah.
What about water?
Well, if it's in solution, you've got all the water you need too. And this is one of the things about redox problems. They're always, almost always, going to take place in either an acidic or basic solution. We're going to talk about acidic ones first. We'll go to basics. It's basically done the same way, pardon the pun, but with one small alteration at the last step. All right? So the fact we're doing this in an acidic solution means we have as many of these and as many of these as we need. We can add water molecules. We can add hydrogen ions to our heart's content. All right. So that's step 1 and step 2. In this case, let's emphasize that you're going to do this with each half reaction. So you're going to go through this process twice. One for the oxidation half reaction, one for the reduction half reaction. Okay? It is a lot of work. But the more you do it, the easier it gets. It'll get to the point where you can do this in your sleep. And some of you will. Question?
No.
Okay. Okay. Step 3. All right? Step 3. Balance the half reactions with each other by number of electrons. So if you do the oxidation half reaction and you see that it generates 2 electrons, you do the reduction half reaction, you see that it generates 4 electrons, what do you have to do to balance them? Okay? If you balance the oxidation half reaction and you see that it requires 2 electrons, you balance the reduction half reaction, see it requires 4 electrons, how do you balance them with each other?
You multiply the first one by 2.
Multiply the first one by 2. That simple. Okay? The fourth step, once you've got the 2 half reactions balanced, add them together and cancel. Add the 2 half reactions together. And cancel. Now, the obvious first thing you should look for as far as canceling is going to be electrons. If you balanced them correctly in step 3, you're going to have the same number of electrons on both sides. They will naturally cancel each other out. You may also be able to cancel hydrogen ions. You may be able to cancel water molecules. You may be able to cancel some other things depending on what the reaction generates. But you want to cancel everything you can. Simplify it as much as you can. And then the fifth and final step, confirm that the final equation is balanced with respect to mass and charge. Equation is balanced respect to mass and charge. In other words, your final equation needs to have the same number of atoms of each type on both sides. It needs to have the same overall charge on both sides. Okay? Now the overall charge is just positive charges and negative charges added together. So it is possible that you have ions on one side and just, pure substances on the other with no charge. That's fine as long as all the charges balance out. Okay. This is a bit of work. But if you will follow these steps as presented, do them in this order, and do them a step at a time meticulously, you'll get the right answer. Are there shortcuts to doing this? Well, yes. I wouldn't recommend that you start looking for those until you've nailed the basics first. Once you've done a whole bunch of these, you may be able to look at some redox problems and just be able to solve them by observation. Do it this way first. Okay? Do it this way until you're really confident and can do it all the time. All right. Not really any shortcuts. Okay, having said all this, let's get back to our problem. Dichromate ion plus chloride ion goes to make chromium 3 ion plus chlorine gas. Okay? So, one of our half reactions was this. We had... Good. That's not good. Cr2O7 minus goes to chromium 3 plus. Was this oxidation or reduction, by the way? This was reduction. Chromium here is a +6, chromium there is a +3. We're lowering the charge, that's a reduction half reaction. Okay? So let's apply the steps. First of all, balance by mass. Well, and that's for everything except oxygen and hydrogen, right? So we got 2 chromiums here. We need to have 2 chromiums there. Okay? Chromiums are balanced. Next step, balance oxygen by adding water. We have 7 oxygens over here. What are we going to have to add over there? To have the same number of oxygen on each side, what do we have to add over there? 7 waters. Okay? So we're going to put +7 H2O. Okay? Now what do we have to do? Yeah, we've got to balance out those hydrogens, so over here we're going to add some H+. How many? 14. Okay? So obviously this is going to have to take place in an acidic solution. You're going to have a lot of hydrogen ion available. What about charge now? What's the total charge on the right-hand side? Since that's the easier one. 6 plus. Good. What about on the left-hand side?